News.com. Dave, when I saw the headline this morning about this announcement, I thought, this is nuts. But there might be some possibilities here, I suppose.
If you were living in 1955 and somebody said in 30 years you're going to have a pocket computer that will basically bring you the library of the world, would you have thought that was nuts?
Yes. Yeah. So I'm a troglodyte. But
no, I think we all suffer from having grown up with a space program that's proceeded in a particular way. And just like the mainframe computer business was the only game in town, all of a sudden someone came along and said, you know, we can put some components together in a garage and do some things that normal people will want to have done that industry doesn't need to have done right away. And a paradigm was changed, a revolution was begun. This could be the beginning of a similar revolution in how we do space.
So we're talking about essentially a privately funded venture, and the indications are that they're going to announce sending rockets up, sending mining equipment up to asteroids and mining asteroids?
Right. Well, there are asteroids and then there are asteroids. There are great big ones that live in a belt between Mars and Jupiter. And then there are some smaller ones that are called Earth-approaching asteroids or near-Earth asteroids. These are the ones that could come and give us a real headache, the ones whose orbits cross that of the Earth. So that's both bad news and good news. The bad news is they cross the orbits of the Earth. The good news is they're in Earth-like orbits, which makes it very economical to get to figure out what they're made of, and to bring things into useful orbits, possibly even all the way to the ground. But I'm not willing to say.
Let me add a note here.
Economical is a relative term, it would seem.
It makes it less inconceivable that we could get to them. However, they are still flying at vast, tremendous speeds. We've never been to them before, and it's going to take an awful lot of technology and innovation to be able to do this. That said, there's a lot of potential there. There's these minerals that barely exist here on Earth. The repositories we have of these things, they're called rare earth minerals, exist on Earth because of asteroid impacts. So we have a tiny amount of them here. There's a vast amount of them flying around at supersonic speeds.
Well, here is what, again, I read the article initially with bemusement because they talk about sending spacecraft up to mine asteroids for things like iron and nickel and water even. We have plenty of that stuff on Earth.
Yes, we do. What we don't have is plenty of water in space. So if you want to expand into the solar system, if you want to become a multi-planet species, if you want to build your own habitats in space, if you want to build Las Vegas in orbit as an entertainment destination, the critical thing that's missing is water. Have plenty of it on Earth, but it costs you an awful lot to build a great big rocket to move an amount of water off the surface of the Earth, out of the deep gravity well of Earth, into some place where you can use it in space. These objects are extremely tiny. They have virtually no gravity well, and as I mentioned, they are in Earth-like orbits. So they're really easy to move that mass from where it is to where you want it to be. And maybe where you want to be is where they already are. Maybe you want to go to one of these targets, change it from its rock-like state to something that looks more like Las Vegas in orbit, and populate it.
All right, so who is talking about doing this, Jeremy? Who do we have backing this mission?
Well, the venture is called Planetary Resources, Inc. We don't know very much about it. Everyone's looking forward to learning in the next couple of minutes. We're going to watch it here live, of course. We know it's backed by a guy named Peter Diamandis, who's a very, very well-known space exploration guy. We know it has a bunch of big names attached to it, although what they're doing exactly remains to be seen. Some of the guys from Google, their names have been floated around there.
Larry Page, Eric Schmidt from Google.
And James Cameron, of course. Who's
Titanic director.
Anything exploration, it's him.
Right.
But beyond that, what's going to happen? We know there's a NASA astronaut as well.
Tom Jones.
Tom Jones, thank you, yes.
NASA handle is TJ. And before he was an astronaut and before he flew B-52s with nukes under the wing, he was, I believe he did his graduate work in asteroid studies, I think at University of Arizona. So TJ comes by this honestly. I think this has been a lifelong passion for him. And he's not an active NASA astronaut anymore, but he's a relatively young guy. He could presumably be on a human crew that goes and visits an asteroid someday. What these guys are talking about, though, is not human missions to asteroids yet. They're talking about robotic missions, which satisfy a lot of your objections, Jeremy.
All right, so let's say you're going to send a robot up to catch an asteroid. I mean, what speed are these things moving at, and do we even have the capability of intercepting them?
Well, we're moving at a pretty good clip, too, through space, right? It takes us only 365.25 days to get all the way around the sun in an orbit with a diameter of 93 million miles. So we are hauling ass, right? So is this object, right? The moon.
That would be the moon.
It's orbiting us as we orbit the sun. Asteroids are in orbits, the ones that these guys are interested in, are in orbits that are similar to the Earth. So it's exactly like two NASCAR drivers at very high rates of speed, but the relative velocity between them is very, very slow.
Okay, so you use that speed to...
Well, you have two objects that are traveling at enormous rates of speed relative to each other, and everything is relative in space, is not such a problem. The delta V, the change in velocity that you need to get from one to the other, is the closing distance between them, right? So this now becomes a much easier proposition than you think it is, despite the fact that everything is whizzing at great rates of speed. What I will say is, when you change the mass of an object, you change its orbit. So one wants to be really, really careful about how you change the mass of an object that already crosses the orbit of the Earth. And there may be some regulatory questions that come into play some years hence when this becomes practical. I think what these guys are going to tell us today is, first thing we're going to do is we're going to look. Because if you're a prospector, you want to characterize the population of stuff that's out there. So they're going to fly their own private telescope. Low Earth orbiting telescope, easy, simple mission to do. Look out there and see what Earth-approaching asteroids have we not identified. Spectrographically, what might they be made of? And will they share that data with the science community as NASA does? We don't know. It's their data.
Question.
They may say, you know, our claim, our asteroid, you guys want to go find out about it, do your own work.
Here is an artist's rendering of what this might look like. There's the good old Earth in the background and some kind of an asteroid in the foreground with that buggy-looking, well, I guess it's a remote mining device sitting on the surface. Not a very big asteroid, or maybe it's a gigantic spacecraft. I can't really tell.
Well, that's the point. You probably don't want to deal with a gigantic one. You only need a little one to make a lot of money. That's what I think Planetary Resources business case is based on. It's somewhat analogous to what the oil industry does, right? Oil industry invests billions of dollars in robots to prospect the floor of the ocean so that they can dig down below the floor of the ocean thousands of meters in order to haul up petroleum reserves that they think are there. It's wildcatting. This is wildcatting.